Hello, everybody. My name is Holt Skinner. I'm a developer advocate for Google Cloud focused on Vertex AI. And today we're going to be talking about building out grounding systems for Gemini with Vertex AI Search and some DIY stuff if we have time for it. So first of all, let's take a look at what some of this stuff is. So we're going to be talking about grounding, which means coffee, right? I think we all could use some at this point in the day. No, that is not what we were actually talking about today. But it's a very clever little system. We're going to be using RAGs to ground our large language models. So that means we're going to be getting our nice dirty dish rags from the kitchen, right? Yes. No, we are not going to be doing it with these types of rags either. So let's do a little definitions, shall we, of what these things are. So first, a quick little definition. What is RAG? First, it stands for Retrieval-Augmented Generation. Right? So let's break all of those words down into what they mean. So generation means using generative AI to make something new, which can be text, images, anything along those lines. And augmented means to be made greater, larger, or more complete. And retrieval is the process of getting something back from somewhere. That's actually the official definition from Merriam-Webster. But in a computer context, it means obtaining or consulting a material stored in some kind of data system. And so what this means is that RAG means we're going to generate text that has been augmented with data that we have retrieved, right? And so retrieval-augmented generation as a whole. And so why do we need anything like this for a generative AI system? So without RAG, we have a few issues with large language models sometimes. Without RAG, the model has to be the only source of knowledge in this, so which can lead to things like hallucination. We could have old information, or there's sometimes we might have data, or might have questions or things that are being asked that we just have no idea what it means, right? And it also, a lot of these models aren't trained on your own data, right? So if you have something that's very specific to like a company use case, or if you have certain terminology or jargon, Gemini by itself is not going to know what that stuff means. You have to kind of feed it the information to say, okay, this is what such and such terms apply to. But with a RAG system, the model is grounded on source data, so we can have citations for what we're asking about. The information can always be up to date if you keep your indexes up to date, and it can be about as comprehensive as a search system. And the data can be either your public data or data that's specific to your use case. So this is just kind of an example of how that might go using some documentation, say from Flutter. The input prompt, you could say, is there a toolkit to make games with Flutter, for example? You could add in like maybe the history of what you've been talking about previously, put it into the large language model, which is trained on data at some point in the past. And we might get a great response like, oh, I'm sorry, there isn't anything that I know about for that. But with a RAG system, you can augment that with search results and then get a more complete answer for it. So now, if you're going to build all this stuff out by yourself, then you have a lot of stuff that has to be implemented in this. And I've tried to do this myself, and it is not easy, but it is possible. Yes, go ahead and take all the pictures you want of this. So first of all, you have to collect the information somehow. And this can be from like a web crawler, it can be from PDF files, from a database, other connectors of some kind. So you have to get all of that in somehow. And then you have to parse it or get into a format that a language model can understand. You can use something like Document AI, or honestly, nowadays you can just plug it into Gemini and get text extraction from it. Gemini 1.5 Pro is actually pretty good at doing that. And so then you have to find ways to chunk all those documents. Even with a large context window like Gemini 1.5 Pro has, there's still some elements where there are going to be some documents that are still too large for that window in some form or fashion. Or maybe you don't want to return, if you may not want the entire document to go in there because there may be a lot of irrelevant information and you just want to get the part that you need in there. And so you also have to find an algorithm to embed all of that. So embeddings, if you're not familiar with it, basically just takes text, images, or something along those lines and turns all that into an array of numbers. And then you can actually do very scalable algorithms like scalable approximate nearest neighbor, or other things like that to find other similar semantic data points to that. And then you have to find some way to store all of that in some kind of system. You can either use a vector database, and performance can be variable depending on what you end up using. And then after you've prepared all of your data, at runtime you have to take the user's query and then run it through that same embedding algorithm, do some kind of searching on it, which you could use like Vertex AI vector search or matching engine, which may or may not work for what you're trying to do, but usually that's kind of the standard at this point. And then you have to plug all of that into some kind of language model, like the Gemini API or Vertex AI. And then you have to find some way to actually serve all of this. So it's something you absolutely can do, and a lot of companies are wanting to do things like this, because if you want all of the control that you could possibly have for this, or if you have a very specific use case, or if you have different types of models you want to use in particular, then you'd have to go this route. But for about 80–90% of people, you probably don't need to do something this complicated. So we're going to go through a few different examples of how to do this. We're going to start with kind of the beginner examples, and if we have time going forward, we'll work on some of the more complicated ones. So let's start somewhere here. I'm going to have to move my computer display around. Mirror for... OK, I made my display a little bit too small. Let me fix that here. OK, let me go back to the slides here so I can show you the QR code again. OK, so first we're going to get started with Vertex AI Search, which has also been, it's had a lot of different names over the year and a half or so that it's existed. It's also been called Enterprise Search. It's been called Vertex AI Search and Conversation, Vertex Generative AI App Builder, Agent Builder. But the term I'm going to be using for it most in this presentation is Vertex AI Search. So we're going to start with just a simple getting started guide. And what Vertex AI Search does is it is a all-in-one kind of fully managed retrieval-augmented generation system on Google Cloud. And so what you can just do with this is basically just kind of yeet your data into it, and it'll get ingested, and you can search over it and build these types of systems with not a lot of effort, basically. It's pretty straightforward to get it started. So this QR code right here will take you directly to this getting started guide. And so we're going to kind of walk through some of that together, and we'll see how it goes. So let me open up the tutorial. OK, everyone should be able to see this here. So with this guide right here, we're actually going to use this really cool feature of Google Cloud Platform, which is on a lot of these tutorials, we actually have guides directly in the Cloud Console that you can access. Right? So whenever I open this up here, I have a sample little project that doesn't have anything set up currently. We're just going to start from the very beginning and see how it goes. So over here on the side, we have this little learning tutorial panel that we can actually go in, and we can actually enable all of the APIs directly from here, and it'll give us instructions as we go. So I've opened up Vertex AI Agent Builder in the console, which you can also search for it on here if you need to. And sure, I'm going to agree for all of this, and I'm going to continue and activate the API. And I could also do that over here if I needed to. And we'll see how long this takes to do. Very nice. And so if you actually didn't know where to go on this as well, there's little things on this side panel in the console that will point you directly to where you need to go. So what I'm going to do is keep on going forward here. I'm going to say, let's see, we are currently on the Agent Builder page. I'm going to click New App, which I've already done, actually. And I'm going to zoom in a little bit because the text is kind of tiny on here. And then on the Select App Type pane, select Search. OK. And if you're offered a choice of generic or media content, click Generic. OK, generic is already selected. And in order to create a website search app, make sure the Enterprise features is turned on, which it is. And I'm not going to use these advanced features for this app at this time, so I'm going to uncheck that. And then in the Your App Name field, let me see. Yeah, if you actually click on some of these little highlighted things, it'll show you exactly where in the UI to click and type things in. So I think that's pretty neat. So I'm going to just put this as IO, actually no, super cool IO test app. And the company name for this is going to be Google. You'd put your own company name in there if you were doing this. And then the location, you can do global, or you can put it in a specific region if you have a reason to do that. OK, and then I'm going to create a data store. And this is what is actually going to contain all the information that goes into this search engine. So click Create Data Store. And then in here, I'm going to select website URLs. I'm going to ingest a bunch of websites into this to get started here. Advanced website indexing is a feature specifically if you are doing this on your own domain. It requires that you verify that you own the domain. You have to be able to go into like the DNS console and access it, which I do not own google.com, but so I'm not able to do that for you today. But if you are using this on your own company data, you would want to click this to access it. OK, and so in the specify pattern, the website for your data store pane, I'm going to put in cloud.google.com/star to index everything in the Google Cloud website. So this includes the documentation and blogs and all of that other stuff. And I'm going to click Continue, and then give the data store a name, like Google Cloud Documentation Site. OK, and I'm going to check that to ensure that this gets imported into our app here, and then I'm going to click Create. And we shall see how fast this thing loads. Here we go. OK, so we've now got everything in here. And this is going to take a little bit of time to go ahead and add everything in there. But so what you can actually end up doing on here, if you go to the preview pane, I'm going to actually do a test query in a minute here. But one of my favorite features of this product is that, let me actually close, let's see if I can open everything here. So you actually have a lot of settings that you can enable for this little widget that's on here. Here we are. So this little preview pane actually shows you what this can look like in your own website. So if you go over to the integration tab, you can put in public access and then put in a specific domain that you'd want to have this thing host on. And then all you need to do is just copy and paste all of this HTML code right here, put it directly into whatever website you have, and then you'll have a widget that looks just like this right here. It makes it very easy to kind of get all this stuff set up. And then you have options for things like autocomplete. You can have people enter feedback. You can turn on safe search or turn it off. So all of that is available in there. And now let's see if this actually works at this point. So if I search for a product like, I don't know, Vertex AI, we should be able to access that. Well, never mind. It might take up to 5 minutes to complete. So we'll take a little step back from that, and we'll go on to one of the next little setups here. But so you have a lot of features that you can kind of go in here to actually, you can also add structured data. You can add unstructured data like PDFs. There's also connectors for things like Confluence and Jira and Atlassian as well, if you have data in those sources. And you can include all of those in a single search engine, so you can access all of that. OK, let's move on to a different example here. So let me go back to the slide deck. OK, so next we're going to show some stuff with grounding. Now, earlier I showed that image of the coffee grounds and stuff, which I should probably give a little definition of what grounding is here. It's basically just, it's that process of actually giving the large language model information based on a specific data source. And so with Vertex AI grounding, you're actually able to provide information to Gemini from either Google search or one of these Vertex AI search engines, like the one we just created here. And so the idea for this is that it can like reduce the hallucinations for it. It can provide up-to-date information, but it's pretty easy to actually get all of that stuff imported in. In fact, once that search engine finishes cooking, I mean, it still only took about, what, 3 minutes to maybe set all that kind of stuff up, which, I mean, that kind of making a custom search engine like that would have taken hours or days even of development not that long ago. So I think it's still pretty cool that we have that in there. So we're going to go through this codelab notebook that is currently being hosted on the Generative AI GitHub repository for Google Cloud. So here's an example of this, or here's just a look at what this repository looks like. So this is actually full of about 100 or so examples for how to use generative AI on Google Cloud. So it's a great resource to kind of get started and learn more about these types of things. So we are going to specifically go through this Intro to Grounding with Gemini notebook. And if you get lost or can't find it, then you can go to the Google Cloud Platform Organization, or Generative AI repository, and then Gemini, grounding, and then Intro to Grounding for Gemini. And so then you can click on any of these places to open it up. So for example, I'm going to use codelab, but if you like codelab Enterprise, then you can use that. Or if you have stuff in Vertex AI Workbench and you want to use it, you're welcome to do so. But I'm going to use codelab here and show the process of it. OK, so when we're using codelab with Google Cloud, there's a few little logistical things we have to take care of. So for example, first of all, there's a little overview of what all grounding in Vertex AI does, which I've already talked about most of what that's going to be. If you want to use a grounding with Google Search, then there is a form you have to fill out just to get access to it. It takes about 24 hours or so for it to get approved and everything. But it's pretty straightforward to set up, and the link is right there. OK. If you don't have a Google Cloud project, you can just set one of those up. But there are links in this notebook that show you how to do that and how to also get credits for it as well. So you have to enable a couple of APIs here. And so first, what we're going to do in the actual code running side of things is we're going to install and upgrade the Vertex AI SDK. And so I have to do some approvals and stuff. And it's going to take a couple of minutes to load. And so what this is doing is it's installing all of the Python libraries that we're going to be using in this notebook. And then this is the kind of weird thing we have to do whenever we're doing stuff in Jupyter Notebooks, is we have to actually restart the kernel, which you can do by either running this cell or by going up to runtime, restart session. You have to do this after you install a new library, just to make sure we have access to everything. And then I'm also going to authenticate this with my Google account. Now, I've already done that in this notebook, so it doesn't show anything up. But if you do this yourself, it'll show up a little thing to log into your Google account and say, I approve codelab to run this stuff on my behalf, blah, 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 blah. OK. And then you have to import in or put in your project ID and the region that you want everything to be run in, which I thought I had already done, but apparently I didn't. Oops. So I'm going to get this project ID that I have right here. Application default credentials could not be set up. Well, that's interesting. We might have to do a couple of things here. So let me get a different project ID for this. Whatever. We probably don't need that. I think we'll be fine. Cool. So now we're going to initialize the Vertex AI SDK. And this is just basically setting that project ID and that region that we defined just a bit ago to be the default for everything. It makes some of the code later much easier. Then we're going to import the Vertex AI libraries. From generative models, we're going to import generative model, generation response, tool, and grounding, and also some stuff to display items as markdown. And then we're going to use Gemini 1.5 Pro, because it's the latest and greatest. And then we have a few helper functions in here to show how to print the grounding response later, just because you have to extract some data from the response in here, so it kind of abstracts that away. And we're going to fold that away so you don't have to see it. So first, we're going to take a look at grounding with Google search results specifically. So we have a prompt here. I live in Austin, Texas, and we recently had the solar eclipse about a month ago, I think now, which is honestly really cool. 10 out of 10. If you have an opportunity to see one, highly recommend it. But so let's say we want to know when the next one is for the United States. So we're first going to tell Gemini, OK, you're an expert in astronomy. When's the next one coming? Now, if we try to ask Gemini about this without any grounding information, we might get some unpredictable results here. Yeah, so if you actually look at this right here, it says the next one will be an annular solar eclipse on October 24th, 2023. I don't know about you, but it is 2024 right now. So this is not quite the next one. This is a little bit old. So if we want to get some more up-to-date information here, we can actually ground that in Google search results. And so what we can do here is we create a tool, which is basically just Gemini's word for like, this is something that you have access to and can give you information. And we're going to do it from Google Search Retrieval. Grounding.Google Search Retrieval. We're going to create an object of this here. And then we're going to pass that into the generate content method of our Gemini model that we just created. And we're going to put that prompt in there that we already have. And then we're going to print out the response from the grounding data. And now let's hope that this works as I expect. Aren't live demos fun? OK, here we go. The next solar eclipse in the United States will be on August 23rd, 2044. Oh, yeah, here we go. Before that, an annular solar eclipse will occur on October 2nd, 2024, but it'll only be visible in Chile and Argentina. It says this information may be outdated, but this information is actually pretty correct here. It's trying to be extra safe here. And we can also see the exact queries that it made to Google search to actually get that information. But there we go. We already have some more up-to-date information than something that we could just get from the vanilla model, right? So now let's take a look at how we would do this with some custom documents and custom data. So we're going to use the Vertex AI Search instance that we created just a little bit ago, which is based on the Google Cloud documentation. And so I'm going to have to grab the data store ID that I created just a little bit earlier. And the data store is going to be in the same project, so I'm going to actually do the TV chef thing of, oh, here's something I already created a little bit earlier. I'm going to go back into Agent Builder. I'm going to grab the name of this data store that's in here. I'm going to grab one for Google Cloud documentation. Oops, let me actually go in here. I'm going to ask it some questions about Google Cloud. I'm going to stick it in there. I'm going to define all these little constants here so I can access it later. So let's say we ask the model a question about object tables in BigQuery and when to use them. Now, I'm not an expert in BigQuery. I don't know if anyone else in here is, but this is something that could probably be pretty useful. So let's first see what it looks like without any grounding in here. If we just generate the content. OK, we actually have some decent information in here. So it says semi-structured data, large complex objects, reducing storage costs for nested data. And then it also describes a little bit of how these tables actually store the data. This is actually a pretty good answer, and I was not expecting it to be that good, actually. So we'll see if grounding actually improves it or not. We might have to try a few different queries to see a good example of that. But so let's actually take a look at how we can plug in these Vertex AI search results specifically into it. So we have to create a little path for our data store, which in this case, the way it's supposed to look is projects/project ID, location/location name, collections, default collection, data stores, and then that data store ID that we copied from there. And we're going to create a tool just like we did earlier. We're going to create a retrieval object based on Vertex AI Search, and we're going to pass in that full data store ID. And then we're going to pass it over into the Gemini API with that tool that we created, and see what the response looks like. That's actually not that great of a response, honestly. Let's try something a little bit different. So let's open up a different data store in here. So this is one that I have pre-created that uses a fake owner's manual for a fictional vehicle called the Symbol Starlight. So you could imagine this as being similar to like proprietary data to a company or something along those lines. It's stuff that Google search wouldn't just have access to, or it's stuff that you would basically have to tell the model ahead of time. So it's a fictional vehicle here. And some of this stuff, it looks a lot like a real vehicle. Fun story, this was actually generated by Gemini. So what we're going to do is I've already created a data store that actually has that PDF and a couple others imported into it. And I'm going to get the data store ID for this. And I'm going to plug it into Gemini and just see what happens. OK. So let's change this query around. Maybe we'll ask something like, I don't know, what is the cargo capacity for the symbol Starlight? OK, and so let's see what the response is without the grounding in here. See, right here. It says, please provide me with more context. What is the symbol Starlight? Is it a vehicle, a ship, or something else? It has no idea what's going on there. But let's see what it looks like with the Vertex AI search results. This is the joy of live demos, isn't it? Oh, here we go. The symbol Starlight 2024 has a cargo capacity of 13.5 cubic feet. Let's actually take a look in the document here and see where it is. Here we go. It's on the 7th page, and it says right here, 13.5 cubic feet. So very exciting. So instead of having to read this whole 22 pages, or you can imagine another auto manuals are like hundreds of pages long, Gemini was able to parse through all of that and give us a nice example of it. Okay, and you can also connect grounding up to the chat interface as well with this if you want to do kind of multi-turn queries like that. Okay, we have a little bit more time here, so let's take a look at one of the more advanced topics, shall we? So we also have a few other options in here as well for different types or different ways of implementing RAG on Google Cloud. Let me enter full screen so it's easier to see. So we have this Vertex AI RAG API, which has now been renamed to Llama Index on Vertex AI. It's a much more kind of modular, but still managed service that you can use. That QR code goes to the main documentation page as well as code samples for it. So if you'd like to take a picture of that, you can. Nice. OK, and then here's a few extra labs and tutorials that are useful for similar use cases here. So we have one for Vertex AI Agent Builder, which is for building chatbots on Google Cloud. So for chatbots that are grounded in real information that you provide it, you can also kind of create, I guess, like you can create playbooks essentially for how these agents are going to interact. It's intended to be very much no-code, low-code, as easy as possible to get started building chatbots. And then here's some of the more advanced use cases. We're going to walk through a little bit of this. I don't think we have enough time to actually run everything in it because some of the setup takes a bit. But this is a DIY multi-modal retrieval-augmented generation system with Gemini, Vertex AI Vector Search, and LangChain. And so for what this actually is able to do is it takes in a bunch of documents like PDFs, it extracts the images out of them, and then you're able to actually ask questions based on everything that's in the document plus what's in the images, right? And it's all connected using LangChain. That's one of the, and then here's the fully DIY without using LangChain. LangChain just makes it a little bit easier. If you're not familiar with that, it's a framework, a very popular framework nowadays in Python and JavaScript for interacting with large language models and building these kinds of connected applications, or agents, as we love to say nowadays. So those are some of the examples here. We're going to go through this LangChain one. I'm just going to kind of walk through some of the stuff that's going on in there, so you can have a little taste of what is going on. Dun, dun, dun. So it is also in the GitHub repository of Power. And this person that I have no idea who it is wrote this. We have a little bit of overview of kind of what Retrieval-Augmented Generation is, which we've already talked about here today. A little bit about what Gemini is, why you'd want to do this. And so there's a lot of libraries that you have to install for this, because LangChain is massive. It has a lot of other things in it. And then you have to also do the kind of restarting as you would in the previous notebooks as well. define your project information, initialize the SDK, import some libraries. Okay, so the first thing that you have to, the way this notebook does it is that we partition the PDF, which means we extract all of the text from it, and we also extract all the images. In this case, this uses PyMu PDF, which is a Python library for accessing that just to get the raw information out of it. It also allows us to kind of chunk. We use some of the LangChain text splitters to chunk the information into a bunch of different little spots, so it makes it easier to search over. And we also extract all of the table elements as well to get the specific data out of it. And then this one uses Gemini 1.0 Pro Vision. You could also use Gemini 1.5 with this. And probably, yeah, you could also use Gemini 1.5 Flash if you wanted to. And so what we do for this is that we generate text summaries of all of the information that's in there, both the text that's in the document and also all of the images and tables and stuff that are in there as well. And the specific reason for doing this is for efficiency's sake. It allows us to have smaller bits of information that we actually have to store and retrieve later. But there's different ways of doing this. This is just one particular trade-off that was made here. So we end up running that prompt on all of the elements that are in the PDFs that we input. And then we do the same thing for all of the images. We get a summary of them. And then we take that summary and import that in, and then run that through the text embedding Gecko model available through Google Cloud, which actually creates those embedding vectors of the summary that we have. And then what we end up doing is we end up using Vertex AI Matching Engine, which has since been renamed to Vertex AI Vector Search. And that's where we actually end up storing all these vectors, because Matching Engine is incredibly fast at actually running the end queries for this. It's able to actually do the comparisons of all of those in like sub-millisecond time, so it's very kind of production scalable. We create an endpoint for it. And then in LangChain, we end up creating a retriever using vector store to load all the documents into that vector store. You can also use Chroma if you want to do ChromaDB, if you're familiar with that and want to use a local vector store. Then what we have to do here, vector stores, vector search databases, most of the time what they do is they just have an ID and then the actual embedding vector in there. And they do that just for a number of different reasons. At least this is the way that Vertex AI Vector Search does it. So what we actually have to do here is we have to also have a separate document store that actually stores the original text for there or the text summary, and then has that ID field in there as well. So we kind of do a one-to-one. We can do a one-to-one matching. We load all the data into there, and then we actually create a chain for LangChain that actually does the query part of it. And so what this ends up doing is it takes the user query, all the information that's in there, it embeds it, and then is able to do that really fast matching with Vertex AI Vector Search, decides, okay, these images and this bit of text is the closest semantically to what this user is asking for, and then returns that, injects all of that data into Gemini, in this case Gemini 1.0 Pro Vision, and a new prompt that's created, and then uses all that information to generate a more cohesive, more complete response for whatever the user's question is. So for example, this notebook uses a data set of Alphabet earnings reports from the last 20 or so years. And so we're able to actually ask a lot of these questions about the information that's in these documents. And this actually shows how the documents are retrieved. And then we can use the invoke method actually to get a response at the very end. So, and the reason I didn't run through all of this right now is that it takes a little bit of time to get all of this stuff set up. And some of it, you know, it would just take longer than we have today. But you can go ahead and run through this at home and try it out and see kind of what sorts of things you can come up with. Okay then, so let me go back to the slides for a second. if it will let me. OK, so we've gone through quite a few options here. So just wanted to say thank you all for being an excellent audience. I know it is a little bit late. Hopefully you enjoyed yourself and learned a little something.